Hi everyone, here is our math problem for today. Three brothers, Alex, Bob, and Carl, traveled to visit their uncle who lives exactly 300 kilometers away from their house. They have a motorbike that can carry exactly 2 persons at a time. Assume that the bike has a constant speed of 60 kilometers per hour. Each brother can walk at 15 kilometers per hour. If the three brothers start at their house at the same time, what is the shortest possible time in which they can all reach their uncle's house? All brothers are brilliant logicians. You can pause the video and see if you can solve this Google interview problem. Now let's solve this problem together. Let's begin by calling Alex as A, Bob as B, Carl as C. Let's develop first a general solution to the problem, and then we are going to optimize our solution. We will let Alex to walk first, and Bob and Carl will ride a motorcycle. Here we go. Alex walked a certain distance. Bob and Carl travel by motorcycle. Then Bob is going to drop Carl, and Bob is going to go back to pick up Alex. Notice that as Alex went back, Alex continued walking and the two met at this point. And then together, they ride the motorcycle to reach the uncle's house. Now the question is this the optimum solution? The answer is no, because obviously, while Bob was picking up Alex, Carl was just waiting at the uncle's house. So there is some time that is not maximized here. So let's develop our optimum solution. First, by looking at the movements, and then second, by assigning numbers to each of the important parts of the trip. Again, Bob and Carl rides the motorcycle while Alex walks. But instead of Bob and Carl going all the way to the uncle's house, Bob is going to drop Carl at certain distance. Then Carl will continue walking as Bob goes back to pick Alex. And then Alex and Bob will ride the motorcycle. And the three of them, Alex, Bob, and Carl, will reach the uncle's house at the same time. This way. In this case, everyone was moving all the time and they all reached the uncle's house all at the same time. That is our optimum solution. And to find the time for this to happen, it is enough for us to just find the time of any one person, either Alex, Bob, or Carl, because anyway, all of them will reach the uncle's house at the same time. Now, let's quantify this solution. This is the first part. Let's identify this point here. Let's call this point as the starting point. This is the finishing line. And let's identify the first point where Alex was located when Bob dropped Carl. So let's call this point as point X. And this junction also, let's call this as point Y. In real time, they're not going to stop. They continue moving. We are marking these points because we need that in our computation. Next, this is what happened. Alex continued walking, Bob went back to pick up Alex, and Carl kept on walking. Let's mark this distance also, and let's call this as point Z and this as point W. And then, let's continue. All of them reached the same destination, that is the finishing line, all at the same time. And the total distance traveled is 300 kilometers. Now let's go back and identify what's the speed in different parts of this trip. So in the first part, let's recall that time is equal to distance over speed. In this first part of the trip, Alex traveled this certain distance, that is the length of segment SX. Bob and Carl traveled this distance, which is the length of segment SY. Then in the second part, Bob traveled from point Y to point Z. That means he traveled the length of segment ZY, while Alex traveled the length of segment XZ, and Carl traveled the length of segment YW. This is the important part that we can assign numbers. The reason is the length of time for these three persons to travel those respective distances are all the same, because this happens simultaneously and we freeze their movement at this point here. We do not know the time, so let's call that time as the variable t. So we now have these three equations. This time and this time and this time are all the same. Time is equal to distance over speed. For Alex, his time would be the length of segment XZ, which is the distance XZ, over his speed walking, which is 15 kilometers per hour. Kilometers and kilometers are cancelled, so the remaining unit is hour. The same explanation for Bob. He traveled the distance YZ and his speed was 60 kilometers per hour. And the expression for the time of Carl would be the length of segment YW over 15. And this time, this time here and this time are all equal. And solving now for xz, we multiply 15 times time, so we have 15t kilometers, that's the distance. And the length of segment yz is 60t kilometers, and the length of segment YW is 15t kilometers. Now, if we let the length of segment XZ, this segment, to be equal to P, notice that YW is the same as the length of segment XZ, so therefore YW has a length also of P units. And since 60t is 4 times that of 15t, then the length of segment ZY can be expressed as 4P. Next, we do not know what is the length of segment WF. Let's call that as the variable R. Then again, as the trip continued, A and B rode the motorcycle going to the uncle's house, and C walked, and all of them reached the same destination at the same time. That means the length of time for A and B to travel and for C to travel until they all reach the uncle's house would be the same time, not necessarily equal to the first time that we identified. So let's call that time as T sub 2. So for Alex and Bob, their T sub 2 would be this length, 4P plus P plus R, and the speed is 60. In the same manner, the time for C would be the same time T sub 2, but that is equal to the distance he walked, which is R kilometers, and the speed of 15 kilometers per hour. Since these two times are the same, then the right side of the respective equations must be equal. And solving now for R, we multiply both sides by the LCD of 60. Then we can cancel out 60 here because 60 divided by 60 is 1. The left side is 5P plus R. Then the right side is 60 divided by 15 equals 4 times R equals 4R. And solving for R, R is equal to 5 over 3P. And that is now our expression for the length of segment WF. So in here, the only distance that we do not know how to express in terms of the variable P is the length of segment SX. And if we can find the expression of segment SX in terms of P, then we can add all these distances and equate that to 300 kilometers per hour, because that is the distance from the starting line up to the finishing line. And then we can solve for P. And then we can solve for the time that we want to find. Let's go back again to the first part of the trip. B and C rode the motorcycle while A walked this distance. And again, the length of time for A and for B and C to cover their respective distances are all the same. Let's call the time here as T sub 3. And let the variable N represent the distance Sx. So T sub 3 is equal to the distance N, and for A, the speed is 15 kilometers per hour because he walked, while for B and C, the distance is N plus P plus 4P, and the speed is 60 kilometers per hour because they rode the motorcycle. Again, T sub 3 equals T sub 3. Quantities that are equal to equal quantities are also equal, and so the respective right sides of these two equations are equal, and we can now express N in terms of P. So again, multiply both sides by the LCD of 60. The left side becomes 4N. 60 divided by 60 is 1. So what's left is N plus 5P. And solving for N is equal to 5P over 3. So this distance can be expressed as 5P over 3. Notice how symmetric our graph is. That is because the three persons have uniform walking speed, and the motorcycle also has uniform traveling speed. Next, we are now ready to find the value of the time. So first, let's add 5P over 3 plus P plus 4P plus P plus 5P over 3. You have here 5P over 3 plus 5P over 3 equals 10P over 3, and P plus 4P plus P is 6P. The total distance is equal to 300 kilometers. Then simplifying, multiply each of the terms by 3 in order to do away with fraction, and solving for P, we have P equals 900 over 28 or 32.14 kilometers. So this P is 32.14. So 5P over 3 therefore is 5 times 32.14 over 3, which is equal to 53.57. And 4 times P is 4 times 32.14, which is equal to 128.57. Then this P is, of course, 32.14, and 5P over 3 is the same as this, 53.57. Now, by knowing these distances, And knowing the speed, then finding the time is a piece of cake. So here is now the technique. Since Alex, Bob, and Carl all reached the destination at the same time, it suffices to just find what is the time of each one of them. Anyway, they all arrive at the same time. So let's review the path taken by Carl. Carl took the motorcycle to travel this distance with Bob, and we can find this distance by adding 53.57 plus 32.14 plus 128.57. That is equal to 214.28 kilometers. Then he was dropped and he walked the remaining distance, and that distance would be 32.14 plus 53.57. So we can find the length of time for Carl to ride the motorcycle up to this point, plus the length of time for him to walk the remaining distance. Then the sum of these two times would be the total time it took for Carl to travel 300 kilometers. So here is now our computation. Using the bike, he traveled 214.28 at 60 kilometers per hour. And walking, he traveled 85.71 kilometers at 15 kilometers per hour. So getting the sum of these two times, for the first leg, it's 3.57 hours. For the second part, it's 5.714 hours. And the total hours is 9.284 hours. And we can express this in hours and minutes. And so this time that we are looking for must be 9 hours and 17 minutes. And that is the optimum time. So indeed, it's not just easy to qualify to work for Google as Google engineer. And these are types of problems that we call as non-routine problems. You cannot just memorize a formula and suddenly there's a one-step application of the formula. You have to design. You have to go back and forth optimizing your solution until logically, mathematically, you are sure that that is the optimum solution. So thank you very much, and we hope to see you again in our next video. Bye.